Welcome to this edition of Fuel for Thought. I'm Mark Rechtin, Executive Editor of S&P Global Mobility. There's a lot of talk about a future of self-driving cars. Right now, we're at the stage of developing and implementing intermediate stage technologies that will be the building blocks of these autonomous vehicles: blind spot monitoring, adaptive cruise control, automatic emergency braking. It's an alphabet soup of automated driver assist elements that will eventually combine to create a vehicle where people can leave the driving to a computer. But a lot of things have to happen before we get there. In today's episode of Fuel for Thought, we'll be looking at the challenges and potential stumbling blocks that automakers, suppliers, dealers, and independent repair shops are having to contend with in implementing these driver assist and safety control systems. A key challenge involves what happens when an owner modifies a vehicle, whether by someone installing larger wheels and tires or because of a repair to a vehicle following a gentle fender bender or a windshield crack. Something as minor as modifying the suspension can throw these highly sensitive systems out of calibration. And that's bad news. Joining us today are three top subject matter experts from S&P Global Mobility: Nishant Parekh, Senior Automotive Analyst; Jeremy Carlson, Associate Director for the Autonomy Practice; and Todd Campau, Associate Director for the Aftermarket Practice. Well, let's jump in right away with Nishant, who is also the author of this month's Fuel for Thought article. Let's talk a bit about ADAS, and also known as driver assist systems. What are the main systems folks might recognize, but also let's explain what is different between a system like blind spot monitoring as opposed to adaptive cruise control, and how prolific are these systems becoming in today's vehicle fleet?
Sure. Thanks, Mark. So some common ADAS technologies, as you mentioned, are automatic emergency braking, blind spot warning, adaptive cruise control, and lane departure warning. Now, as our listeners would know, these systems, of course, enhance the safety and comfort of a vehicle, but they also serve as a springboard for more advanced automated features. These systems were initially the mainstay of luxury cars, um, but they have become more common in mainstream vehicles. And of course, that trend is now growing. Let's take a look at what these systems do and how they differ from each other. Now, a blind spot detection system monitors the dangerous blind spot area using a camera or radar sensors or both, and it warns the driver of a forthcoming collision during lane changes. Now, that's different from automatic emergency braking, in which the system detects the distance to the vehicle in front and then it assists in avoiding rear end collisions. And it does this by applying the brakes if needed. Let's also now talk about how prolific these systems are becoming in our vehicle fleet. In fact, according to our autonomy forecast, more than 60% of vehicles sold today globally have 10 or more ADAS applications. And actually, in the US, 15 automakers have pledged to make automatic emergency braking standard in their new models by the production year that began in September 2022.
Okay, Nishant, thanks. And you brought up an interesting technical perspective, and we'll move to Jeremy for this one. Driver assist technologies can use cameras or radar or lidar. Which systems tend to use which technologies, and which ones seem to be most poised to advance driver assist and automated driving systems?
Yeah, it's a great question, and honestly, the best answer is that there are so many different ways that automakers can bring together these perception sensors, camera, radar, lidar, ultrasound, to make those systems smarter and more aware of what's happening around the vehicle. Radar and camera are by far the most common in the industry today. They're very much established technologies. There's, of course, innovation happening within those segments, but they've been around and installed in vehicles for decades at this point. Now we're starting to see LiDAR sensors coming into some vehicles, but really only to enable the highest levels of automated driving, the functions where the vehicle is doing the most amount to replace or support the driver. In the industry, we would call these kind of level two plus, and especially level three. Um, that said, most of these vehicles today, certainly most of the vehicles on the road today, If they have ADAS content, it'll be supported by a camera or a radar, and most of them already include both of them or multiple, especially if you've got a blind spot system where now you're adding two further radar sensors into the back corner. But I would say the most common configuration, and in particular, as we think about an application like automatic emergency braking, they're going to be based on a camera behind the windshield and usually a radar sensor somewhere up behind that front grille to create this kind of redundancy in sensing in this very safety critical forward area.
Okay, I think we were able to narrow down kind of what all these systems do. Thanks a lot for that. Okay, Todd, let's talk troubleshooting. These systems are very precise and may not operate well or at all if they're thrown out of calibration. What can cause this?
Really, there's a myriad of factors that could cause the systems getting out of calibration. I think in your introduction you mentioned a few: changing the ride height, putting a lift kit on your Jeep or your Bronco, putting new tires on it, um, even taking the bumper off to make a change to um, the radiator or something in behind. Uh, if you don't attach it, at the same angles and everything, it could uh, cause the system to be thrown out of calibration, as well as obviously the little fender benders and bumps that maybe in the past you wouldn't have worried about so much. Any of those things could cause a front end system to get out of alignment. Uh, Further, things like a cracked windshield. I mean, if your windshield gets cracked, um, if it's not replaced and calibrated correctly, then the camera that Jeremy was mentioning that is behind that front windshield could be impacted as well. So there's a whole myriad of factors really that go into maintaining the vehicle. And now with radar, potentially LiDAR, cameras, and other sensors in bumpers and on mirrors and on the front and back corner of the vehicle, these critical areas that historically were um, probably some of the top areas for the little accidents we might have with our car, bumping into a post or something at the store or whatever. It used to just be a mirror that cost a few $100 to replace, but now, if you hit your mirror and you got a camera on it, you're talking about a much more extensive replacement and a need for calibration. So, just about anything we do to our car that alters it from the original design and shape of the vehicle could, they won't always, but could have impact on these safety systems.
Okay, thanks. Let's take it back to Nishant. Let's talk about who works on these systems, the kinds of tools and surroundings that are required, and the difficulties that these technicians will face, whether it's an automaker's franchise dealer service department or an independent tune-up shop.
Yeah. So from the industry conversations that we've had, and even multiple conversations with the service industry, what's clear is that as the number of ADAS equipped vehicles rise, so will the need for accurate and reliable calibration services. Now, when it comes to franchise dealers, they have several options for offering these ADAS calibration services. They can say either choose to offer in-house calibration, or they can call a mobile ADAS calibration provider, or they could even send vehicles out to a standalone ADAS calibration facility. When it comes to an independent garage, typically they have sublet the ADAS part of the service to external entities, but this is now starting to change. Some garages, especially those into services such as, say, wheel alignment, for which ADAS calibration is really critical, and it also goes hand in hand. Now they are starting to take control of ADAS work. Uh, these garages are upgrading their facilities to cater to this business, primarily because of two things. This, first of all, allows them to control the profits, and also crucially control the cycle time of the repair process. They can sort of hand over the vehicle back to the customer in a much shorter time frame if all of this is done in-house. Now, speaking of doing it in-house, there are some essential requirements that must be met to sort of properly serve ADAS vehicles. These requirements are related to physical space, adjustable lighting, and also flooring. As an example, let's take what Bosch Diagnostics uh, requirement is for their calibration device. What they say is essentially the service bay should be at least 34 by 25 feet for bare minimum calibration services, but actually they recommend 45 feet by 30 feet. Now that's significantly large area. Uh, Talking about other requirements, light, that's also very crucial. The calibration area needs to have uniform lighting, um, one that doesn't flicker or cast heavy shadows. Uh, in fact, the floor of the calibration space also needs to be as level as possible. This is actually with no more than a 10 difference across the floor, according to what Bosch says. Um, and Now this is truly interesting. They in fact say that the attention also needs to be paid to the area outside the calibration area, in the sense that the floors and walls outside the area should also have one solid neutral color. So these are broadly some of the critical requirements for conducting ADAS calibration.
Okay, so ADAS repair is certainly not for the generic shade tree mechanic. There's a lot of requirements involved. Let's circle back to Todd. You mentioned replacement cost of these parts, and they're very expensive to replace. But you also can't really measure the societal cost that these systems carry in terms of accidents they prevent, right? I mean, it's one of those greater good equations.
Yeah, I mean, really, I think the question really is more, what is the cost of not repairing these systems? I mean, when we look back just a short few years, if you use the your iPhone as an example, um, 20 years ago when um, I was out of college, but let's pretend I was in college 20 years ago. I was on a flip phone and I lived my life on a flip phone and I never thought anything about it. But now my children coming up couldn't imagine a flip phone. They can't imagine a phone that's not a smartphone. Um, and they're more technology native than I thought I was when I was growing up. It's going to be the same for cars. The children that are coming up in this era and upcoming in the coming years, they're going to expect to be able to rely on these systems to work. And so for me, yes, absolutely. Absolutely, they're very costly to replace, but the question of the cost really, for me, sits on the other side of the equation is what is the cost not to repair it if a child gets behind the wheel or even an adult down the road who's relying on that front collision system to work and it doesn't work. Um, I've been driving cars for a lot of years now, and I still it's kind of a safety net for me that to have the front collision system. But in the not too distant future, it's going to be expected. And so, I think the cost will, as this evolves, the cost will begin to um, come down as well. But really, that's where I would place, as you said, it really is a greater good equation right now. In that, if we're putting these on vehicles and people are expecting them to work, then they need to work. Otherwise, the cost will be far greater than the cost of the repair.
Okay, let's get back to Nishant. Now, for this article, in addition to all the good data and analysis that we have here at S&P Global Mobility, you talked to the folks at SEMA, the Specialty Equipment Market Association, and they represent the aftermarket companies that make all the fun add-on toys for cars and trucks. But those toys can pretty quickly mess up the calibration of ADAS systems. How does SEMA approach this issue?
Yeah, so it was very interesting actually to speak with SEMA about this. They've been in the thick of the action when it comes to vehicle customizations and its impact on ADAS. So they say that they are continuously researching on behalf of its members to create what they call a series of best practices. These practices relate to the proper ways to address ADAS on modified vehicles. Basically, they've even opened an ADAS center that's equipped with the tools for both static and dynamic calibration. It was also interesting to learn about some modifications that are popular with vehicle customizers. Um, and this also ties in with what Todd said earlier about the impact of the changes to a vehicle on the ADAS calibration. So SEMA says that they've observed that uh, suspension components, wheels, and even oversized tires for pickups and SUVs are the ones that are preferred quite often. But like we've discussed, they say that any modifications to these are most likely to need recalibration of the OE ADAS sensors. In fact, a change in the tire diameter or even the ride height, um, as we discussed earlier, has the potential to throw off these OE ADAS sensor readings. Ultimately, what SEMA says is that it will be important for customizers of newer model vehicles to sort of learn how to work with ADAS, because um, this will be critical to ensure that modified vehicles and their onboard safety systems are all of it are working within the factory specifications.
Okay, Jeremy, we're going to move on to you now because it's been a little bit. Let's talk about planned obsolescence. And these systems are going to improve rapidly, but that raises the issue of automated driving tech that's bleeding edge right now, but could be considered ancient in a decade, and which perhaps cannot be modernized with something like an over-the-air software update. And if the trend continues where the average age of cars on the road is more than 12 years, as we recently chronicled, that means a lot of first gen ADAS systems will still be around in 2035, 2040. And for anyone like me who owns an older car, I have a 2008 BMW 535i, finding someone who knows how to work on this once cutting edge stuff can be difficult. And with manufacturers wanting to maintain chain of custody over their technology, and let's be straight here, fighting tooth and nail against right to repair laws, might that limit customer choice in terms of who can work on these cars?
Yeah, I mean, it's a great question, and it does point towards the direction that we're heading. And it's one of many really challenging questions that the industry and all of its, participants and supporters and enablers have to contend with. Vehicles are becoming much more complicated, certainly is true, and I think these automated driving systems really exemplify that growth in complication, complexity, but just capability about what we're asking the vehicle to do on its own. I don't think there's anything else in the automotive industry that really reflects how much that is changing, and starts to raise really some of these big fundamental questions that the industry as a whole needs to contend with and find a happy answer to. We've talked a lot about driver assistance systems, and those are fairly straightforward. They typically don't have a lot of what we call sustained control. It's emergency only. They absolutely have to work very well or to the best of their ability in those scenarios. And everything we're talking about today really reinforces that they need to work as intended to have the intended effect. Ultimately to save lives, or at least to, let's say, reduce the effect of a crash. This becomes even more complicated, however, when these advanced driver assistance systems, these supports, are becoming much more well integrated into regular operation of the vehicle, what we would call automated driving systems that effectively replace the driver in kind of all forms of vehicle control. Drivers do have to supervise those systems, But this automated driving system is capable of everything that the vehicle needs to do, let's say at least in most kind of normal circumstances. That is going to continue to get even more complex here as we see what we would call level 2 plus and level 3 systems coming into new vehicles. And then we're asking this question about chain of custody, life cycle support, how long do you support these systems? And it just becomes that much more complicated in the future. What is really interesting to think about is that question around chain of custody. Yes, automakers are fighting for it, but if we think about these automated driving systems, there's also a very important and good reason for them to want to maintain that chain of custody and to ensure proper operation of the system. At some point in an automated vehicle or an autonomous vehicle, the liability shifts from the driver to the automaker. And when that happens, and then we experience a crash or a fault in the system, or a vehicle modification, takes them out of compliance and out of operation, or they're not working very specifically as intended, then that impact now has to come back to the automaker, right? It's product liability. And it's that kind of movement and this trend that we see that makes this an even more difficult question than it has been. And unfortunately, the complexities of this technology, we're not going to reverse that anytime soon. These are technologies that can have very significant life-saving effects on vehicles on the road for pedestrians and non-vehicle participants. But as we've talked about today, we've really got to get them right and make sure that they're supported for the long term, which, yeah, to your question, will get more difficult over time because these systems are different for every manufacturer. They're often different for every vehicle, or at least for multiple vehicles within an automaker's family. And of course, maintaining that knowledge over time about how to support, hundreds of different vehicle configurations, not to mention the software builds that make those hardware configurations work. Yeah, that's going to be a challenge.
I can see a whole new generation of product liability lawyers just salivating at this, and we haven't even gotten into the trolley problem yet, and we don't have time for that. But let's go into a lightning round. So Nishant and Todd and Jeremy, which ADAS technology, in your opinion, holds the most promise?
Yeah, for me, it has to be the most popular one, adaptive cruise control.
Okay, Todd.
Nishant, I think you stole mine, Nishant. I like the lane keeping. It's part of adaptive cruise, but I like lane keeping.
Interesting. So I'm really split here. Automated driving, I think, has a huge amount of potential because it's a convenience feature and drivers want it and they're willing to pay for it. We've seen that in our consumer surveys. But I think ultimately, when we boil it down to safety, for me, it's going to be automatic emergency braking. That forward crash type is one of the most common in the industry, in the world, and it often has the most kind of severe impact. And being able to avoid that, or at least scrub off some additional energy before impact, yeah, there's a lot of life-saving potential there for me.
Yeah, I think everybody thinks that they're a good driver, and then there's that one time that automatic emergency braking really saves your bacon, and you suddenly realize, yeah, that computer just saved me from something really horrible from happening. So I'm with Jeremy on that one. All right. Obviously, we have just scratched the surface of this issue, and we could probably delve into many more related issues confronting the industry, but our time is up. Thanks to our experts for joining us today, and thanks to you for listening. That was a lot to unpack, but I hope you all feel smarter and more informed for having tuned in. And if so, please share this podcast link with your colleagues and social media accounts. And to opt in to our newsletter that provides more information on this topic and others, please visit spglobal.com/mobility. And if you want to learn more about this topic, please feel free to reach out to our experts at that same web address. We'll be back with more fuel for thought next month.